Hi everyone, welcome to SPLC. I'm Luca Favalli, PhD student at Università degli Studi di Milano, and today I would like to show you our research paper Neverlang and FeatureIDE just married. I hope everyone here likes tiramisu, because it turns out that language product lines and tiramisus are pretty similar. How's that? Everyone thinks they know how to make tiramisu, but in reality there is no such thing as tiramisu. What you have instead is a bunch of similar but different products that are belonging to the same family of dishes, the family of tiramisus, but they are different enough to be categorized as different dishes. The same goes for general purpose programming languages and even more for domain specific languages. So you can create variants of the same language and hence creating language families. There are some neat examples of language families in literature, so I suggest you go check them out. But how do you create a family of tiramisus? Well, you have to start from scratch, so from the ingredients, and you have a collection of all the ingredients that are available in your kitchen, and you can combine them into several recipes. The same goes for language product lines, where you have a collection of language components or language features, and you can combine them into a compiler or interpreter. So this creates a language variant, and to achieve this result you usually need a language development tool or a language workbench. Now we know how to make a family of tiramisus, but how do we make it good? Well, we argue that to make a good family of tiramisus you need a fancy restaurant, and this restaurant should have a few characteristics. First, it should be in Italy, and second, it should provide for the needs of a few different roles. The first, it's un pasticcere, so someone who can provide you with the best ingredients. Second, there is the chef, so someone who can combine those ingredients into a recipe. And since the two of them are opening a restaurant together, I think it's best if the two are married. Okay, but I think we are also forgetting someone else. You can make the best tiramisu out there, but it's not much worth if nobody is eating it. So you also need customers. Now, how does the restaurant support the activity of the three roles? Through an engineering process. The language developer is the first, and the developer can work in a very fancy kitchen and prepares language components and lists them into a description with some useful information called feature model. Next, you have the language deployer that inspects the feature model and combines the features from the feature model to create language variants. So what it would be the menu of the restaurant. Last, the language user inspects the menu and chooses the variant they prefer to eat. If there is some new requirement or issue, the diagram is traversed the other way around, so the language user has to complain to the language deployer, and the language deployer has to complain to the language developer. This is kind of convoluted, but please let me show you an example to make it more clear. You have a very healthy language product line with many variants and a lot of cool features. However, one day a new user comes in and asks for something different. The language deployer inspects inside the feature model to see if there is a feature available to implement the behavior asked by the language user, but it turns out that in reality there is no such a feature. So the deployer complains to the language developer, and the language developer, thanks to the great kitchen that is made available to the developer himself, then can create said language components. Next, we have the deployer again, that since the language component has been added and the feature model updated, can now create a new recipe, so a new language variant that implements the requested behavior, and now the language user can just pick this new language variant and taste it. Okay, where's the problem then? In reality, there is no environment, so no restaurant that nowadays supports the activity of all the three roles. What you have instead is some kind of environment that supports for either the developer or the deployer, and that can be used to create tiramisus that then the language user has to take and bring home, and it's at home. To overcome this obstacle, what we did was marrying the state-of-the-art in software product line and language product line engineering, hence namely FeatureIDE and Neverlang IDE, to create an integrated language product line development environment. As you might see from this picture, the language product line development environment in this picture is divided into 3 layers, one for each role, and shows that the views that are made available for each of the roles. On the first layer you see the editor for language features and the view for the feature model. On the second layer you see part of the configuration process for a language variant, and in the third layer you see some editors and the consoles that the user can take advantage of to actually use those language variants. But let's see it in action, shall we? Okay, so the language user wants to create a simple implementation for the factorial of 5 using a JavaScript variant. So the user implements the script and executes it, but unfortunately the execution yields an unexpected result. So what the user would like to have is a variant that logs all the assignments to variables so that it can be used to spot the bug in the script. The language deployer now inspects the feature model, but no feature implements said behavior. Luckily, using the Neverlang editor, the language developer can now implement the feature for logging of assignments, and the environment automatically updates the feature model to include the new feature. Last, the language deployer can undergo the configuration process and include the newly created functionality, so the new feature, into the configuration. The language deployer also adds a new compilation phase so that the logging is actually performed. Now the user only has to run again the implementation for the factorial, and the console will automatically log all the assignments to the console. Thanks to this new feature, the user is now able to spot and to fix the bug. Executing the script once again will yield the correct result. Okay, to showcase the suitability of this environment for the engineering process that we showcased, we ran an experiment for gradually teaching programming and JavaScript in particular. In this experiment, we developed in an incremental and distributed way 14 JavaScript variants of increasing complexity, with the addition of one variant for the complete JavaScript language. To simulate the distributed process, we used Git, and here you can see some of the commits that were necessary to implement variant number 8. The Git was made available online, so please go check it out if you're interested. In conclusion, our contributions are: first, a language product line engineering process that supports incremental and distributed development process of language families, and that can handle conflicting requests from different users through variability, meaning that we do not have to prioritize among different requests, because we can simply provide a different conflicting configuration to different users. To support this engineering process, we married the state-of-the-art in software product line and language product line engineering, so FeatureIDE and Neverlang, to support the engineering process, and we developed an integrated language product line development environment that ensures consistency preservation, configuration, deployment, and usage of language variants inside language families. I hope you enjoyed my presentation, and I will try to do my best to answer any of your questions. Thank you.